All right, let's jump right in. Today, we're taking a look at a really powerful new way to fight financial fraud. And you know what? It all comes down to seeing the bigger picture. And wow, what a big picture it is. That number you're looking at? Over $400 billion. That's how much credit card fraud is projected to cost over the next decade alone. It is a massive, relentless problem.
But what if the solution isn't just about building a slightly better trap for each individual bad transaction? What if the real key is a total shift in how we look at the problem?
Well, that's because fraudsters, they don't operate in a vacuum. They're smart. They build these complex, hidden networks to cover their tracks. And the traditional methods? They're stuck looking at one transaction at a time. They're constantly playing catch-up. They're reactive, not proactive. So this is the crucial shift in thinking. The old way treats every single card swipe as this isolated event. But the new way, it understands that fraud is basically a team sport. It analyzes the entire network, all the connections between accounts, merchants, even devices to get the full context. And how exactly do you see a whole network? Well, you have to start thinking in graphs. This is really the aha moment of this whole thing. Instead of just a long, boring list of transactions, you start to see this giant interconnected map of all financial activity. And to put it simply, a financial graph is exactly that, a map. You can think of every account and every merchant as a location, like a city or a landmark, and every single transaction, that's a road connecting them. All of a sudden, you're not just looking at points on a page, you're looking at pathways and relationships. And this slide from Capital One's research really shows how it works. The AI takes a simple transaction list, like the one on the left, and it starts playing detective. It sees, okay, one account was used at both Amazon and Walmart in a short time, and it goes, that's a connection, and it draws a line. Now, just imagine it doing that for billions of transactions all at the same time. That's how you build this incredibly detailed network. And this is where our hero technology comes in, graph neural networks, or GNNs. As NVIDIA points out, these AI models are built specifically to understand these maps. They don't just see the individual cities or locations. No, they analyze the roads connecting them. They see the traffic patterns moving between them, and they can even spot entire neighborhoods of connected accounts that just don't look right. But honestly, it gets even more fascinating. The AI doesn't just see the connections, it actually starts to understand what they mean. It builds its own internal map of how the world works just by looking at transaction patterns. And this right here brilliantly illustrates the result. Without a single human telling it what fast food or airlines are, the GNN just figures it out. By seeing which merchants are visited by similar customers in similar ways, it groups them together. I mean, look at that. Burger King and McDonald's are right next to each other. Nike and Adidas had their own little neighborhood. It's learning the categories of commerce all on its own. Okay, this is where it gets kind of mind-blowing. The AI starts to learn abstract concepts. On this slide, it has learned the idea of high-end versus affordable. Just look at how the line connecting Gap to its more affordable sibling Old Navy runs in almost the exact same direction as the line connecting the super luxury Ritz-Carlton to the more budget-friendly Fairfield Inn. It figured out the concept of a price point, and it saw that relationship is consistent across totally different industries. Insane. All right, so this all sounds incredibly smart, but does it actually work any better? Let's put these GNNs to the test, head-to-head against some of the other leading AI models out there. And the results from the research are, well, they're pretty stark. Just take a look at this table. Right at the top, you've got GraphSage, which is a type of GNN, hitting 97.5% accuracy. It is the clear winner. It's outperforming even really powerful traditional AI models like XGBoost. Now, you might think a couple of percentage points isn't a huge deal, but when you're talking about billions of transactions, that tiny difference represents millions and millions of dollars in stopped fraud. Seeing the network gives it that decisive edge. But here's a really cool twist. In the real world, you don't actually have to pick just one. The smartest approach is to build a team. You use the GNN for what it does best, finding those deep, hidden patterns in the network. Then, you feed those powerful insights to a more traditional model like XGBoost, which is fantastic at making simple, clear decisions. So you get the amazing pattern-finding power of the GNN with the explainability of the old method. It's literally the best of both worlds. So, after all that, what does this incredible tech actually mean for businesses? And maybe more importantly, what does it mean for you and me? So what's the real advantage here? Well, maybe the most important thing for us is it means fewer false positives. Because the system is so much smarter about context, it means fewer of those awkward, totally frustrating moments where your own legitimate purchase gets wrongly declined when you're at the checkout. On top of that, its higher accuracy means more actual fraud gets caught, and its scalability means it can keep up with our crazy fast-paced world. That's the real-world difference.
And that leaves us with one last thought to chew on. This whole idea of thinking in graphs is a really powerful one. I mean, if understanding the hidden network of connections can completely revolutionize fraud detection, just imagine what other massive complex problems we could solve, from tracking diseases to optimizing supply chains, if we just learn to see the connections.